Hi everybody, and welcome back to this week's episode. Today, we're going to be replacing the CPU in this here oil-filled computer. So a little information about what we're going to be doing today. As you remember from last episode, we talked about how the computer, whilst I got the cooling system operating, the CPU wasn't up to par as far as operating the systems that we wanted to operate, specifically the editing software. So I picked up a cheap but worthy upgrade. It's not the latest and greatest by all means, but it is almost the highest end chip that this motherboard can handle. So to walk through a couple specifics of this, replacing a CPU is not all that super difficult. There are some things you have to keep in mind. One of which being these are very, very sensitive to static discharge. So don't go walking around dragging your feet on the carpet and then touching things with it and such alike. Even what I'm doing right now is probably not a good idea. So do as I say, not as I do. It's a terrible, terrible thing to say on a YouTube video. Anyhow, specifically, they're not that difficult. Things you have to keep in mind: avoid static discharge. AMD uses a style of socket where the pins are actually mounted to the CPU itself. So you have to be very careful with these here pins. If they get bent, you have a very small chance of bending it back without breaking it. If they break, then your CPU is likely kaput, bricked. You may get away with something as small as just having only half your RAM available, but chances are you done bricked it. Now, I'll tell you this, something you guys probably already noticed. This is the old CPU, which is why I'm so callous with it. I already replaced the new CPU in there. Thankfully, I recorded the footage. I recorded footage yesterday, no, 2 days ago for this, but I was not happy with the footage. So we're reshooting it today so I can be a little more happy and hopefully make a better product for you guys to actually pay attention to. But, or at least enjoy. I hope you guys enjoy this, I really do. So yeah, try to avoid static discharge. Be very careful with the pins. Now, Intel sockets don't have pins on the chip. They put the pins on the socket. So for example, I can show you, this is an Intel socket. And when I say socket, what I'm talking about is the receptacle that the CPU sits in. So this is the socket that the CPU sits in. Now this has a little cover over there, so we're gonna see if we can't remove that cover. So I'm just gonna pull this up and out of the way and remove the safety cover. Now if you'll notice, this socket is designed for an Intel CPU. The pins here, and again in this case the socket is super delicate. You don't want to bend one of these pins because again then you ruin a motherboard, which is actually cheaper than the CPU. So I'm kind of okay with that idea in that respect, but exactly saying you can see, like it's hard to see on the camera, I know, and I don't really have a very good zoom in feature here yet, but you can see there's lots of little pins. Like you can see this grating. In fact, if you get the handy dandy pocket knife out here, I might be able to point it out to you. You'll see each one of these here little dots is a pin, and they are offset. They're offset to provide a little bit of spring tension in that pin so that when you push the CPU against it, there's like a good spring connection going on in there. It's got a little bit of pressure to maintain a good connection. So that's the difference here. Alright, so Intel, the pins are in the socket. AMD, the pins are on the CPU. Each one has their benefits. Personally, I kind of like Intel's idea because the CPU then is at least a little more resilient. But either way, now you know them a little more. So, small detail. This, again, is a AMD chip for what's called an AM3 Plus socket. And this, specifically, is for a chip that I need to get in the future that we're going to experiment with. This socket is for, it's called an LG1151. I don't know exactly all the generations it fits, but I know it does fit the 7th and like 8th generations, I believe. I don't think it's the 9th generation. So like the i5, i7, I think even the i3, there's versions of the i3 that fit the LG A1151 socket. Either way, so at least you know there's different sockets. Each one has a designation, and they are designed for specific CPUs. When they come out with these CPUs, these are designed for a specific socket. So when you're building a computer, and the whole reason I'm leading up to this is because eventually I want to show you guys how easy it is to build your own computer. I built my own computer back in 2012, and it was actually not very difficult. And I built this thing from scratch. I didn't even have a case. I literally built the framework and everything from Lexan to fit into a case because this is what I wanted to do with it. Either way, it's not that difficult. I didn't have a bloody clue what I was doing. I knew that you needed a motherboard, and you needed a processor, and you needed, you know, cooling, and you needed a graphics card. Other than that, I really didn't have a clue what I was doing, you know, sticking everything together. Either way, future video, we're going to build a computer, and I'm going to show you guys how easy it really is to build your own computer. You can save yourself a small amount of money and be proud that you did that yourself, kind of thing. So that'll be future. For now, let's just get into replacing this CPU. So you'll notice the very first thing we do is we drain the oil. Something unique to this computer and any computer that is an oil bath style computer. So we have to drain the oil so we can get to all the components. Then we can actually get into removing the heatsink, removing the CPU, cleaning things up, putting the heatsink CPU back in. You don't want to put the heatsink in first. Putting the CPU back in, because then you'd have to like put it through the heatsink. So you'd have to do like a Vision. Like Vision's gonna hold onto your CPU and like move it through the heatsink and then like place it right between in the socket there. That's ridiculousness. I'm being silly. You put the CPU in, you put the heatsink on, there's thermal paste, there's procedures, how to do it, there's alignments and stuff. Let's get into it, let's go over it. I'll probably should say a little bit of a trigger warning for those of you who are noise sensitive. Just because of my setup, I'm going to try and edit it out, but you might hear some mouth breathing because I was so close to the microphone and it's kind of disgusting, so I apologize. It's not very easy recording everything that happens with an oil-filled computer. Actually, it's not really easy doing a whole lot of things with an oil-filled computer, to be very honest with you. It's just kind of neat, I guess. It's not the last time you'll see oil-filled, but it is kind of inconvenient. Either way, let's get started. Alright everybody, so now we're going to go in here, now that we have the oil drain down, Some of you may be like, oh, you gotta let the thing drip dry a little further. Well, hey, you know what? No pain, no gain. We're just gonna get a little messy with it. So with the AM3 socket, the way this works is there's a crossbar that hooks on here and then has a little lever back here that pushes the heatsink against the CPU. So I'm gonna loosen that, which unhooks this side, which then unhooks that side. I'm gonna give it a little twist. Now I'm giving it a twist so that I don't just pull the CPU right out of the socket. There we go. All right, now I unplug the CPU fan and I can just remove this right out. So that removes our heatsink, and we're just gonna let that sit on the paper towel here, drip dry off, and we're good to go. Now I'm actually noticing that I have my Corsair RAM, my Corsair DDR3 16 gig. It's a 16 by 2. So 1 8 gig stick here. It looks like there's some schmutz from what may have been the old CPU paste. Did a little smutchy dripping down on that rail, so I might just pull that out and clean that up while I'm at it. Yeah, it looks like there's some schmutz dripping down in there. All right, now I'm gonna take a paper towel and I'm gonna clean off the majority of that thermal paste on the CPU so that when I pull that out, it's not quite as much of a mess. All right. Now, if I'm not mistaken, there's a lever that pinches the CPU pins in place to help hold the CPU in place. And that lever is right here. So what I need to do is unlatch it and then let it fall. And that allows the CPU to be unpinched. Now, one thing I have to note, whenever you're putting a CPU onto a motherboard, there's always a specific orientation. It's usually marked by a triangle. So I'm just going to look before I pull it out and find the triangle or any identifying marker that lines up with a marker on the motherboard. That way I know when I put the new one in that it goes in the same direction. And there you have it, ladies and gentlemen. We have removed the old CPU. Now we're just going to go through and clean this up a little bit. Like I said, there's some schmutz down in here. Get the majority of that. Wipe it up. Then we're going to pull the RAM out and clean that up a little better. So I'm just going to go ahead and pull the RAM out now. When you're pulling the RAM sticks out, there's notches on the side, on each side. Some of them only one notch folds open, but on this one it's both. So you want to flip those open just like that, and they'll actually push the RAM stick out a little bit, and then you just grab it and there you go, pulling the RAM out. Now again, I'm doing this because there apparently some smuts up on the RAM stick, which you can see pretty clearly. Yeah, there you go. That's some of the old thermal paste off the CPU. So you guys know, I put that CPU on back in 2012-ish, and I hadn't changed the thermal paste until recently, and so it looks like that's what's left over of it. Kind of nasty, but we're going to clean that up, stick that back in there, clean up the sock a little bit, and then prepare to stick the new CPU in. Alright, so here we are at the motherboard again, and we're going to go ahead and stick this RAM in place. Now you'll notice that the slots are open, the latches, so there's a notch right here that lines up with a notch in the PCB right there. So just go ahead and slide her on up in. Straight if possible. And then you push until it latches. Apparently my heat spreader is not exactly happy with that either. Well, one of the disadvantages to building a computer under oil. Stuff eventually falls apart. Alright, no biggie. Yeah, that one's... Alright, so we pull this here lever down. We grab the new processor. Also be careful not to touch the pins on the back of the processor. Not that you're going to ruin it for life, but they are gold, and touching them, the oils from your hand can get on there and tarnish things up. So you'll notice, as I said, there's a triangle right here that you can see on the board faintly. So we're going to put this in, lining that up. Now, when you do this, it doesn't take force. Like, it doesn't take force at all. Like, literally just wiggle it in, say, all right, you're in place. And then you just push this up until it latches in. And there you go. There's your CPU in place. We're gonna take a paper towel, wipe that off a little bit. All right. Now we're cleaning that off because we want the best possible surface for the thermal paste that is going to go on there. And the purpose of the thermal paste is to help conduct the heat from this here IHS integrated heat spreader onto the heatsink, just doing its best job to get rid of the heat. So we're going to have to reapply that, and you want a clean surface to put that on. So I'm going to prepare, I'm actually going to modify the heatsink a little bit. I have a couple other fans I want to use, possibly get more fluid flow through it. So I'm going to prep that, and then we're going to mount the heatsink onto the CPU. Alright, so here's the point where all the computer nerds get all kinds of opinionated and critical. Application of thermal paste. In this case, I think it's pretty straightforward. This isn't a large CPU, it's not overly massive, so we can go with the industry standard. What they say is a pea-size amount of thermal paste right in the middle. So we're going to go with that and apply a pea-sized amount of thermal paste right there in the middle. Now, to be very clear, the thermal paste is non-conductive. Thermal paste hasn't been conductive for a long time, not unless you get the super cheap stuff. Now, we didn't go all out, but we're using the Arctic Silver high-density polyadditive thermal compound. Now, I know because of looking it up that this is non-conductive, which means if the thermal paste oozes out anywhere, i.e. onto that RAM slot, it's not going to conduct electricity and blow anything up. So honestly, you're better off with more than risking not enough. So that being said, there you go, your pea-sized amount of thermal paste on the CPU. So now we're going to take the heatsink, if I can manage to get it in here straight, and put that on. See if I can do it without bumping the camera. All right. Get that wire out of the way. Oop, fell out of the notch. To be fair, I am not a fan of the AM3 heatsink mounts, but that's what we got. So I take the one end, I'm latching it over, I'm pushing that on, I'm taking this, come on, there we go, and I'm gonna latch that over, pull the lever down, there you go. Now me personally, I like to give it a little bit of a wiggle, let it settle in place, let some of that thermal compound ooze out a little bit. But that being said, be very careful doing that because obviously you don't want to break anything. Then we're going to come in here and plug the fan back in. Now I know I said I was going to modify this thing. I wanted to put a second fan on the heatsink, but turned out the fans I had were 140s, not 120s. So I didn't have a fan that would actually physically fit on there. So we're just gonna keep what we got. All right, now here's the important part. We are going to turn on the system before we put the oil in. Mostly because I don't want to have to pump all the oil out again if this CPU doesn't actually post. So we're going to turn on the system, see that it posts, and hopefully it does, and then we put the oil in. All right, let's do that. So now that all the dirty work is done, and my hair's a mess, so this is our old 6100 CPU. This thing I really don't care about. Maybe I'll try and delit it. I don't know. Either way, it's trash to me. I also went ahead, while the computer was apart, I went ahead and took out one of the graphics cards because I really honestly don't think it was doing a whole lot of good for the computer. And I may be able to use it to bench test the processor and do some other experimental work that I need just a GPU. Because the processor I'm getting doesn't have a built-in GPU, so I would need a dedicated GPU to do that. Nothing fancy. All I want to do is operate the CPU and heat it up. So this would get the job done pretty easy. In fact, I may not need it, but we're going to use it anyhow. So let's go ahead and turn this sucker on. Now I have everything back up and running. The oil circuit's running, the cooling circuit is running, and she's got to post up. Alright, so we're going to keep hitting the delete tab to get into the BIOS, RAID, and BIOS. So let's see what we are doing. Total memory here, 20 gigs, 2480, DDR3, 1333, which is slow as balls. So that one RAM stick that we put in there, I did confirm it's just the heat spreader that's kind of coming off. Again, that's one of the downsides to the whole mineral oil thing is stuff just eventually decomposes. The glues, they even say the thermal paste decomposes eventually. Well, I haven't really seen that so much, but that's what they say. Alright, so model name, BIOS version, build date, compliancy, system language, access level. We've got advanced. Let's go to system 1, overclock is normal. Let's go ahead and change that to automatic, and I'm going to change it to this because I don't know, maybe it'll make a difference. GPU phase control, we're just going to leave that in auto. I am not an overclocking master by any means. So, in fact, I barely even know what I'm doing with the overclock. I just know that it's possible. And thankfully, this thing has some automatic features to do that, just that. Alright. No, I don't want to quit just yet. Let's see, chipset, Southbridge, Northbridge, advanced CPU configuration, HTC temperature limit, L2 cache is 2 gigs, data cache is 16, 2,000 bytes, 16,000 bytes. L1 instruction cache, 64 bytes, 8 core, running 4 megahertz. So right off the get-go, we are at, not only do we have 2 more threads, 1 more physical core, 2 more threads, but we're running at 4 megahertz instead of 3.6. So right from the get-go, right out of the gate, we're doing better. Are now enabled. Core leveling auto. All right, all this stuff is pretty much normal. So we're going to go out of here, save, and exit. So now it's going to reboot, and we're going to run through a couple tests. I tell you what, man, I'm a mess. I need to put a room air conditioner in here or something, because I am just sweating buckets. All right. Immediately we see 12% RAM usage, CPU disk. What's our metrics? 30 degrees Celsius, 29 and dropping. Right now we're sitting at a case temperature of 72.9 and dropping. So about ambient. The only advantage we have right now is the fact that oil transfers heat so much better than water does. But even that is kind of negated by the fact I can only move a little bit of oil through the heat exchanger at one time. So we'll see. I am going to run Cinebench. Oh yeah, I need to go to download documents, downloads, open, open, open. All right, Cinebench. Right from the get-go, 2 core, 4 core, 4 core, 8 threads. So we should be in the realm. We should be in the realm of an Intel Core i7. Should be. So let's see how this works. Now I know as a matter of fact, and maybe I'll be able to screenshot this in there, but I know as a matter of fact we were running 390 was our best shot on the 6100. And right in here I can tell you right now, 4 cores, 8 threads, 4.3 gigahertz. So the overclock worked. We're up to 4.3 hertz on this thing. All right, let's run this. This might take a little bit of time, so I might just fast forward. Well, there it is, ladies and gentlemen. That definitely shot us up into the up in the scales. So we're doing better than, well, according to Cinebench's charts here, we're doing better than some i7. So we went from a 390 score to a 644 score on the CPU on Cinebench R15. So that's probably still kind of poor, but it's a hell of a lot better than what we had. So that being said, we're going to try doing some other things. We're going to see if we can't get the editing software to function now and make things work a lot better. Again, CPU replacement really isn't that difficult of a thing. Keep in mind, static is an issue. Static discharges on CPUs can pretty much brick them. Your thermal paste application is important, but you're better off with more than less. Better safe than sorry. So that's non-conductive. Almost all the thermal paste you can get nowadays is non-conductive because nobody wants their product to blow up your computer. So they make it non-conductive unless you get the like seriously cheap crap. So this is fine. So you know, if you have too much and it drips over, it's not going to blow anything up. So again, you're better off with more than not enough. Or you just follow the whole pea-size thing recommendation, or you can watch one of the millions of videos out there with people showing how to apply thermal paste on a CPU. In fact, Gamers Nexus did a great article on he tried different application patterns and to see what difference they made. So thermal paste is in. That's our old CPU. Pulled out our video card for future references, future projects, and she's running. Thank you very much for your patience, ladies and gentlemen. I know the picture quality wasn't exactly 100% because, I mean, it's really hard filming through a fish tank and just working around in this little room and trying to work around everything. But thank you very much for your patience, and appreciate all your views. I appreciate all your support. So go ahead, hit subscribe, make sure you're subscribed, make sure that bell icon is struck, and like it if you liked it, dislike it if you didn't like it. And if you didn't like it, by all means, tell me why. I'd love to know. Thank you very much, ladies and gentlemen. Have a good night.